In this video, we're going to talk again about how to graph a linear inequality. So the first step in graphing a linear inequality is to graph the boundary line. And the way that we graph the boundary line is to turn our inequality into a linear equation and determine whether the points on that line, the boundary between two regions, determine whether the points that are on that line are also going to be solutions to our inequality. So first we're going to turn our inequality, y is greater than or equal to 2x, into an equation by changing the inequality symbol to an equals. So we have y equals 2x. We now need to determine from the inequality symbol whether or not the points that are on the boundary line are also included in the solution. So if we look over here, we see that we have a greater than or equal to symbol. The or equal to part indicates to us that the points on the line y equals 2x, the boundary line, are also part of the solution. Therefore, we know that we need to have a solid line to denote our boundary. So the next thing we need to do is graph this line, y equals 2x. Now, one way of graphing, generally we'll start with looking at the x and y intercepts. That's one of the easiest ways to do that. But in this case, if we drew that, we'll soon find out that this line crosses through the origin, which means that the x and y intercepts are both the point 0, 0, which means that we can't use the x and y intercepts because they're the same point, and we need two different points to be able to graph our equation. So we can use the point 0, 0 because that is definitely a point that solves this equation. 0 equals 2 times 0. 2 times 0 is 0. 0 equals 0. And so what we're going to do is pick another point to be able to graph. And we can choose any value of, let's say, x, and just find out what that value for y would be. So I'm going to say that let's pick a number that x equals 2. And we want to find out what is y going to equal when x equals 2. So we'll say y equals 2 times x, which is 2. Well, 2 times 2 is 4. So when x equals 2, y is going to equal 4. Okay, now again, if you didn't know that the point 0, 0, that it goes through here, you could randomly pick another point, say x equals 5, and in that case y would equal 10. But now I have 2 points, so I can start graphing my line, my boundary line. So I have my axes here. Here's my horizontal x-axis and my vertical y-axis. So now I'm going to plot these 2 points. So 0, 0 is obviously the origin. So I'm going to plot that point. And the next point that I have to plot is 2, 4. So 2, 4 is the point where x equals 2 and y equals 4. So I go over to x equals 2, I go up 4 spots, and I get y equals 4. So now I have my 1, 2 points. I can now draw a line. And I go back and remind myself that the boundary line includes the answers to the inequality, so therefore it's going to be a solid line. So I'm going to draw a solid line through those 2 points. And that is my boundary line. And it distinguishes a boundary. I now have an area on top of the line and an area below the line. And remember, this is supposed to cross through the origin. So the solution to my inequality is going to be all the points on the line and then the points either on top of or below the line. So we need to determine that. So the next step is to test a point. And I pick any point that's either on top of or below the line and find out if that makes the inequality a true statement. And if it does make it a true statement, then that point falls in the solution area. If it does not make a true statement, then the other side is the solution area. So again, in the past we've talked about how the origin is always the most convenient point to check. However, because our line passes through the origin, we know the origin is going to make this a true statement, so we need to find a different point. And again, you can pick any point you want. So I'm going to just test the point 2, 1. Okay, we can see that the line clearly does not go through this point, x equals 2, y equals 1. Okay, here's my little test point that I'm checking. So I'm going to test that to see if it makes the inequality a true statement. If it does, then I'll shade that side that includes that point to be the solution set. Otherwise, we'll shade the other side. So we're going to plug this into our formula. So we have our inequality as y is greater than or equal to 2x. So let me substitute in my values. So y, which is 1, is that greater than or equal to 2 times 2? So is 1 greater than or equal to 2 times 2, which is 4? No, it is not. So this point, 2, 1, is not part of the solution set. Therefore, the bottom half of this grid, the points underneath our boundary line, are not solutions to the inequality. Only the points on the top of the boundary line are solutions to the inequality. And if you want, you can test that by picking out another point on top of the line. We could pick, the point 0, 4, because that is clearly not on the line and in this upper zone. And again, if we plugged it in, we have 4 is 4 greater than or equal to 2 times 0. Is 4 greater than or equal to 2? Yes. So therefore we do know that this is in the solution zone.